We're looking at the metal displacement reactions, which has got to do with the reactivity of metals. So you've seen in class when we put some lithium, sodium, potassium in water, that some metals are more reactive than each other. The lithium would have just, fizzed maybe a little bit, and the potassium has probably sparked and maybe caught fire and spat water around because it's more reactive. So some metals are going to be more reactive than others, and the reason has got to do with how easily it loses its valence electrons. You don't need to understand why or how, because you get a list here of, well, here is an example. Let's draw on that. Here's an example of a reactivity list where sodium is the more reactive metal and copper is the less reactive metal. And where this becomes useful is if we have a metal that's kind of tied up in a compound, like, say, some iron ore in a rock, and we want to get the iron out because we want to sell it to China or whatever. So we can find a more reactive metal than iron, which in this case, like we've got iron down here, we find a more reactive metal that knocks the iron out and takes its place in the compound. So let me just write some notes for that. So what I'm saying is that a more reactive metal will replace a less reactive metal in a compound, leaving the less reactive metal in its elemental form. So we'll get iron as an element, which is just iron, which is what we want, because we don't want to be, posting heaps of rocks away on ships. We just want the iron, right? And this type of reaction is what Western Australia is built on. So it's kind of nice to know where all our money comes from. So I'll write that out for you. We've got iron sulfate, for example, is an iron salt. I'm not saying that that's what's in the iron ore rocks, but iron sulfate is a salt that contains iron. If you want to get the iron out of it, you look up the list and you find something more reactive, like, say, calcium. And you're going to end up with these two metals switching places. So you're going to end up with calcium sulfate and iron, which is what the thing that you were looking for in the first place. Yeah, of course, it helps if the more reactive metal is a cheaper one, or you can extract it back again some other way, and you can reuse it over and over again, but we can use it to get the iron away from the sulfate. So here's another example. You've got some copper sulfate, and you want the copper. So you look here, where's copper? And you go, we'll get something more reactive, like sodium, for example. And these two metals are going to swap places, right? So I've put the charge up here for you so that you can write the name of the salt. Sodium's only got 1+, sulfate's got 2 minuses, so I'm going to need 2 sodiums. So we're going to have to go sodium sulfate and copper metal. So what you're going to see, what you will observe when you do this is you might see a colour change, because copper sulfate is a blue colour and sodium sulfate is probably a totally different colour. In fact, I don't think it's coloured. So you'll see a colour change, or you might see some kind of metal forming on the bottom. You might see your original metal dissolving. So you'll see a little bit of bubbling where your original metal is being taken up by the sulfate, in this instance, and you might see a different coloured metal being formed in the test tube. So they're the sort of things you observe. So in the experiment that you're doing, you're going to mix different metals with different salt solutions. So these salts that you're given, they're soluble, they're dissolved. So you're going to mix the dissolved salt with a metal and see if there's a reaction. And if there's a reaction, it means that you've put it with a more reactive metal. If there's no reaction, you've put it with a less reactive metal. And you're going to try and come up with an order of reactivity for the metals that you've been given. Then you're going to write the equations just like this with the metal being replaced. And then you're going to balance them. So first one's good. We've got an iron, a sulfate, and a calcium. Calcium, a sulfate, and iron. Perfect. But this one needs a 2 there for 2 sodiums. SO4, Cu, done. Okay. Hope you figure that out.